Hello everyone, welcome to lesson 6-1. Solve one-step addition and subtraction equations. This lesson is found on page 437 of your workbook. An equation is a sentence stating that two quantities are equal. Okay, that's what we say equation, and you can find the root word of igual. Okay, equal, the same. So this side is supposed to be the same as this side. That's why we have the equal sign. The value of a variable that makes an equation true is called the solution of the equation. So if we can replace a variable, a number that we don't know, with a number that makes the equation true, that makes it valid, we call it the solution. So let's look at the example here. We have x plus 2 is 6. Well, what can x be to make this true? Okay, so that would be the solution if we can solve. Well, a number plus 2 is 6. Remember, this side is the same as this side. The only one that makes sense would be 4. 4 plus 2 is 6. Well, let's see. If I were to subtract 2 from this side and this side to make the equation true, remember I'm going to remove 2 from here and 2 from here so that I only have the x left, and whatever number I have left over here, I would have x equals 4. And that makes sense. Now, another way that I've taught you in the past, or we've discussed in class, is to isolate the variable. So leave the x on this side of the equation by itself and take this positive 2 to the other side, this plus 2 to the other side. This is called inverting the operation. So you isolate the x on this side and you invert the operation by taking this plus 2 and doing the opposite on the other side. So that now it's gone from here and it's on this side, but it becomes the opposite. Right? You do the opposite operation. So now you have x equals 6 minus 2, which is 4. The equations x plus 2 equals 6 and x equals 4 are equivalent equations because they have the same solution for 4, which is 4, for x, which is 4. Circle the equations below that are equivalent to x equals 3. Use algebra tiles if needed. Well, let's see. If I were to replace all of these x's with the value of 3, would it be true? Let's say I do 3 here. Okay, 3 and this x. Let's zoom in. If I replace the x with 3, 3 plus 3 is 6. Yes, this one is true. Okay. If I replace this x with 3, 3 plus 3 is 6, not 3. So no, that one's not true. Okay, moving on. Let's see. X plus 1, so this would be 3 plus 1 is 4, no. And over here, 3 plus 1 is 4, yes. Right? Replacing all the variables with 3. And again, if I write a 3 here, 3 plus 6 is 9, so no. And then 3 plus 2 is 5, that one makes sense. So that's what you should have. Real world connection, video games. Robin had some video games, and then she bought 4 more games. Now she has 10 games, right? So she has some video games. We don't know how many. That can be represented with a variable. But then she bought 4 more games. So we have x number of games, which we didn't know that she had, and now we have another 4 equals 10. So what can this number be? Now remember, if we were to solve this, we isolate the x so that the x is by itself on that side of the equation, and we do the opposite operation on the other side. We bring over the 4 and invert the operation. It's plus 4 on this side of the equation, so it's going to be minus 4 on this side of the equation. Right? So x equals 6. So what does x represent in this equation? The x represents the number of games Robin started with before we added the 4. Write 2 different equations that are equivalent to x plus 4 equals 10. Well, I know that x equals 6, right? We just solved that up here, x equals 6. So that's one equation, and I can use that same concept and say 2 times x, 2x, which would be 2 times 6, equals 12. There we go. Copy those down, please. Okay, a key concept for today is subtraction property of equality. So we're going to use the subtraction property of equality. It means that it states that the two sides of an equation remain equal when you subtract the same number from each side. So similar to addition, when we subtract from both sides, it must remain true. So it's saying a minus b will be the same as B minus C. So you see I'm taking C away from here and C away from here, meaning A is B. You see A, it will be equal to B. Please take a look at example 1 and follow all the steps carefully. Do the same with example 2. Now remember, boys and girls, it is very important that you actually pause the video or look at your books and take the time to follow these steps. Remember, I am trying to get you to learn from your books, but I'm providing this additional step with the video to guide you through it. But eventually, you have to be able to pick up a book, look at the examples in the book, and learn it on your own. So to save time now, go ahead and do that. Pause the video and take a look at these steps. I hope you looked at those steps, and I think you might be ready now to do this, try these on your own. If you are, please pause the video, try it on your own, and then check to see if you got it correct. Alright, I hope you paused the video. I'm going to go ahead. Now, here we have y plus 6 equals 9. So we're looking for y. I'm going to write it again, y plus 6 equals 9. I'm going to isolate my variables to write y equals 9 minus 6. I went ahead and took my plus 6 on this side and inverted the operation, so I brought it to this side. If it's addition on one side, it's going to have to be the opposite on the other side. It's going to be subtraction, as you can see right there. So y equals 3. Does that make sense if I were to replace it here? 3 plus 6 equals 9. Yes. B. X plus 3 equals 1. Wow, we are adding 3 to it, but it's going to be less. That means x has to be a negative number. It has to be a negative number that I add 3 to, and it gives me a positive 1. Okay, so let's try to figure that one out. Let's see. I'm going to isolate my variable so that I have x on this side equals 1 minus 3. See that? I brought my adding to this side and it becomes subtracting. So now I have x equals negative 2. Right? Because if I take 3 away from 1, I'm going to go into the hole by 2. And now I have negative 3 equals a plus 4. And I'm going to isolate my variable where I just write a all by itself. My adding 4 will come to this side where now I have negative 3 minus negative 4. So here I have 1, 2, 3 negatives, and here I have 1, 2, 3, 4 negatives. Altogether I have 7 negatives. So negative 7. So a equals negative 7. Example 3. An angelfish can grow to be 12 inches long. If an angelfish is 8.5 inches longer than a clownfish, how long is the clownfish? So 8.5 inches longer than the 12 inch. So I know that I can add this plus this and it will give me 20.5. That's not what we're asking to do. But we have to express the clownfish using algebraic expression, right? Where we pick a variable. Now clownfish, I might choose C. I might choose C for clownfish. And I believe that's what they did down here. So words. An angelfish is 8.5 inches longer than the clownfish. So the angelfish. So the angelfish is 12 inches long. It's 12 inches long, and that means it's 8.5 longer. Okay. Let's use a variable. Let C represent the length of the clownfish, as we were just saying. So now we have the equation. So we have 12. 12 is the total. The total of the angel is the clownfish plus 8.5. Remember, the angelfish is 12.5 inches longer. So it makes it a total of 12. And if we were to find the difference between these two, because this is how much longer the angelfish is, we would find the length of our clownfish. And you know that if you were to invert the operation and bring this 8.5 over to the other side, it would become subtraction. It's addition on this side of the equation, it becomes the opposite on the other side of the equation, so you would subtract from 12.5 and you get 3.5 inches. Let's try the example. The highest recorded temperature in Warsaw, Missouri is, wow, 118 Fahrenheit. My goodness, you could boil an egg on a car with that. This is 158 degrees greater than the city's lowest recorded temperature. Find the lowest recorded temperature. So clearly, boys and girls, we're looking for the difference between these two. Now we could just simply subtract it, but how can we write it algebraically speaking? Well, algebraically speaking, we're saying that we have 100. Oh, let me use white because you can see better. We have 118 degrees, and we know that 118 degrees is the highest that it's been, right? And we have 158. This is 158 greater. This is 158 greater. So plus the temperature we're looking for. So 158, this is 158 greater than the lowest temperature we're looking for. So the lowest temperature plus that much is going to be this, the hottest. Okay, so it's 158 greater. So clearly, this is a negative number. Let's isolate the temperature we're looking for. We isolate it by writing the T on its own, and we bring this addition to this side and it becomes subtraction. So now we have 118 minus 158. And I think you can tell that it's going to be negative 40. And we can put our symbol right here. Fahrenheit. Oh, I did that backwards. It's degrees Fahrenheit is your temperature. Let's look at the addition property of equalities. Much like we did subtraction, now we're going to add. Okay, so A equals B if A plus C equals B plus C. Okay, if we're adding them, it's going to equal the same. Let's look at example 4. So we have x minus 2 is going to give us 1. What is x? What number can we subtract? So I know that if I have a 3 here and I subtract 2, it's going to give me a 1. You can see that by looking at it. But what is the process that we need to follow? You see here, they're adding 2 to this side to get rid of it. They're trying to get rid of the 2, so they add the opposite. But whatever you do to one side of the equation, you must do to the other side of the equation so it becomes 3. That's the way the textbook is showing you. I've shown you to isolate the variable and invert the operation, and that's what we're going to do.